Hello, this video is going to help with isosceles and equilateral triangles. So let's start with going through the different theorems and the corollaries that they give us in the book to go by. Okay, so let's look at this first. First of all, what is an isosceles triangle? An isosceles triangle has two congruent sides. So if you look at Theorem 20, this is an isosceles triangle because this side is congruent to this side. So you have two congruent sides. Now there's different theorems about these. And the first theorem here, Theorem 20, says if you have two congruent sides, so are your angles. And I swear we've actually done this in the last section as well. But just so you know, if you have the sides congruent, then you also know the angles have to be congruent that are on that same two sides. Make sure you're not looking at angle here and here, but here's the two sides, here's the two angles. All right, the Theorem 21 is similar. It says, well, what if you have the two sides, or two angles? Then it implies the two sides. Okay, so you can start with the angles or the sides, and you know that all of them are congruent. Then Theorem 22 is gives us a lot of information here. It says, all right, so if this side is congruent to this side, and we cut it straight down the middle, and we bisect this angle, then we also know that these two are congruent as well. So that kind of is a crazy one, but basically, if you have two congruent sides and you draw a height down the middle, then these two will be congruent, the angles are congruent, and you got a lot more pieces that are congruent. And that's by Theorem 22. So equilateral triangle means all sides are congruent. So corollary to Theorem 20 is saying, well, if all your sides are congruent, we know that's equilateral, then so are your angles. So all your angles have to be congruent. So those go together. Also switches it around for corollary to Theorem 21 is, all right, now if all three angles, then all three sides. So if it's equilateral, it's equiangular as well. Or if it's equiangular, it's also equilateral. Whoosh! Okay, so that's like all of our theorems to go with this. Now let's see how we use those. So here's my first example. Let's see, maybe I'll use this here. Okay, so if this is my first example right here, ABC, and I know it's isosceles because these two sides are equal, what is going to be the measure of angle C if A is 60? Well, we know that these have to be congruent, so it is 60. Okay, so the measure of angle C is 60. All right, what about this one? We know these two angles are congruent, so what's the measure of angle A if C is 53? Well, the measure of angle A is also 53. We also would know that AB and side CB are congruent, so you might be asked something like that. All right, oops, I'm kind of showing the answer. Cover that part up. Okay, so looking at this number 3, this triangle, maybe I'll zoom it in just a tiny bit here. Maybe. Okay, so looking at this triangle here, we know it's isosceles, and it says this one's 30 degrees, and this angle is what? All right, how could we figure this out? What does all three triangle sides add up to? They all add to 180. What do we know about this angle if these two, or excuse me, what do we know about both these angles if these two sides are congruent and it's isosceles? We know that this angle also has to be the same degrees, so we could call it x as well if we wanted. So we know that the two angles, so x plus one more x, because it would be x degrees plus one more x, plus the 30 has to equal 180, right? So adding all three up has to equal 180. So that's the same as 1 plus 1x is 2x plus 30 has to equal 180. So take 180 and subtract it, the 30 from 180. And I'm going to get 2x equals 150. Divide by 2, and x is 75. All right, so 75, 75, 30. So that's how another way you could kind of use the idea of an isosceles to find something. All right, so my next one, let's see. Let's see here. Where's some paper? There's some. Oops, I gave the answer over here. Oh well. All right, so if this is our triangle here, and we know these two sides are congruent, and we know that one's 42, and it says, well, what is one of these? Well, what do we know? If these are congruent, we know if that one's 42, what does that one have to be? It has to be 42. And if this one and this one are 42, this whole one, they all add to 180, right? So let's find this whole one, and what do we know about what this does, this height, what it does to this angle is it cuts it in half. We already know that. So we can do 42 plus 42 plus, we'll just call it y, this whole angle y. We know that this has to equal 180. So once we get this whole thing, then we can split it in half in order to get our x number here. So 42 and 42 is 84. So I'd have y plus 84 equals 180. 180 minus 84 is what, 96? And then half of 96 is 48. So let's see. So we got y equals 96. So we know the whole thing is 96. And so we know that x is equal to 96 divided by 2, which is going to give us 48. All right. Oops, I didn't show all that, did I? There we go. Here's my work again. So we know the whole angle is 96, then x is half of it, which is 48. Okay. Here is another one. Oops. Okay, so we know we have a triangle inside of a triangle, and this one's 50 degrees, and this one's, I don't know, this one's, I don't know, and we know that these are both isosceles triangles. Then how could we go about answering this one? Okay, so I think I'm going to have to do this one. This one's a little bit more work, so I'm going to have to do it on another piece of paper here. So let's sketch that. I'm going to have to draw it over and do it on this other paper. Otherwise I won't have any room for what it looks like here. It was way prettier when I made it the first time, but that's okay. This one's 50 degrees. I want to know this one, and I want to know this one. What degrees each of those are. Okay, so the first idea that I thought of, well, is this whole angle is x plus y. Okay, so I thought of this angle is equal to x plus y. That was like my first thought. And if this whole angle is x plus y, so is this one. Because the big one's isosceles, these have to equal each other. And then those two plus the 50 have to add to 180. So my first thought went, well, we know x plus y from one angle plus x plus y from the other side plus 50 has to equal 180. All right, so we know this. What else do we know? Well, if we think about it, this one is 90, and then these two have to be equal. So we can find y here because y and y. So we would think of it as 90 plus y has to equal 180. And these are the two bits of information that I can get from the big triangle and the little triangle. So if you look, this one has an x and a y, this one only has a y. So this one we can solve and find y, and then we can put our answer back up here to be able to solve and find our x. So y plus y is 2y, so I'm going to have 2y plus 90 equals 180. And then subtract the 90, and you have 2y equals 90. So divide by 2, and y is 45 degrees. So both the y's are going to be 45 degrees. Now we can use the knowledge of the top one to solve for x. So really this is like x plus x, 2x, y plus y is 2y. So another way to write that same formula is going to be 2x plus 2y plus 50 equals 180. Now let's put in our 45 here. So I'd have 2x plus 2 times 45 plus 50 equals 180. 2 times 45 is 90. 90 plus 50 is 140. So 90 plus 50 is 140. So I have 2x plus 140 equals 180. Then from here, subtract over your 140, and you're going to get 140. 2x equals what? 40. And then divide, and x is 20. Divide by 2. So x is going to be 20 degrees here. We're going to have 20 degrees here as well. All right, does that work? It's 45 and 20. So 45 plus 20 makes these each 65. So 65 plus 65 is 130. Plus 50 gives us 180. So it works for the big triangle here to all be 180. Because this one plus this one's 65. 65 plus 65 plus 50 is 180. So it worked. And that's a little bit harder one that uses isosceles. Let's do one more, and that will use equilateral. All right, I got to use a ruler. I cannot sketch these and like them at all. All right, so 1, 2, let's see, this side's going to be, that doesn't quite look as pretty as I wanted it to. Oh well. It doesn't look as good as it should, but you'll get over it. Okay, here is my triangle, and I know this one over here is 60, and these three sides are equal. We're going to call this one in degrees, and we know this whole angle here is 90, and we know this one over here is m degrees. Okay, here's what I'm given on this problem. This is what, our 6th problem, I think. So here's what I'm given. All right, and it's asked for m and n. Well, how could I get m and m? Well, m and m, that sounds like a rapper. All right, so here's equilateral, means we also have equal angles. So they're always going to be 60 degrees. So we know that that's 60 degrees up here too. Well, we know this forms 90. So what does this n have to be? N has to be 30, right? 60 and 30 make the 90 here. Well, then we just look. 90 plus 30, this m is going to have to be 60. All right, so yeah, that one wasn't too hard. But anyway, equilateral means equal angular, so that means the angles would all be 60 if it's equilateral. So you can kind of use that knowledge. Hopefully you find this helpful for section 12.5 on isosceles and equilateral.